Today we have tornadoes, not as science, but Pamela's studio, which is having some bad weather, so pardon the booms and flashes.
We also have science, volcanoes on Mars, comets near Saturn, and a healthy dose of marsquakes.
And rockets and rovers and more.
All of this now, right here on the Daily Space. I'm your host, Dr. Pamela Gay,
I'm your host, Eric Mattis.
and we're here to put science in your brain. When we look at the two sides of the moon, they look so different as to appear to be different worlds. The near side is a mix of light regolith and vast seas of dark mare that people often see as the man in the moon. The far side, the side we don't get to see as the moon goes around and never shows us its back, that far side is just craters next to craters, all in the lighter colored material. How the moon ended up this way is a matter of debate. The moon's high-density core is off-center, which is also weird. To try and piece all this weirdness together, we have to look at the history of our Earth-Moon system. Once upon a time in the early days, a Mars-sized object hit what was trying to become Earth. In the collision, both worlds were destroyed and a bunch of lighter crust materials splashed away, while the two higher density cores merged together to create our planet Earth. As the lighter material orbited the Earth, it somehow eventually ended up in a single moon. But it may have done this in two steps, with the bulk of the moon coming together, and then getting hit by a smaller pocket of leftover material that we now see as the moon's far side. This explanation gives us layers of material to make the moon's core appear off-center, and it may explain the difference in appearance. But the details just don't all come together, and when scientists see inelegant data, they often go looking for a better solution. And that better solution may have just been published. In a new paper in Science Advances that is led by Matt Jones, researchers describe simulations of the impact that created the moon's South Pole Aitken Basin. This is the second largest crater in the solar system, and when the moon was struck, the energy of the impact was transformed into heat, and that heat, the models say, traveled through the moon. With the heat, there was melting and movement of material through the lunar interior. Another way of saying that is the asteroid impact created magma, the stuff of volcanoes, and it flowed through the moon carrying the specific chemistry of the material we see in the lunar lava fields. As Jones puts it, how the chemistry of the lava formed is arguable, the most significant open question in lunar science. And the South Polar Aitken impact is one of the most significant events in lunar history. This work brings those two things together, and I think our results are really exciting. I have to say, I think this is exciting too, and I love how impacts are both digging down deep and building up the surface of the moon in different ways. This week, there has been a new round of headlines that basically boil down to NASA discovers giant comet headed toward the Earth. Yeah, I feel the need to break this story down, make sure everyone knows we are actually safe, and give you the info you need to join us in laughing at some of the more sensationalistic stories hitting the internet. Here's what is true. There is a big old hunk of mostly ice, some rock, and bits of organic material that is entering the main part of the solar system. This comet, C 2014 UN 271 Bernardelli-Bernstein, or burn, is about 80 to 85 miles across, which for a comet is huge, record-breakingly huge. It is also darker than coal, so think dirty snow from a really, really polluted city. Since we live in the main part of the solar system and the comet is headed toward the main part of the solar system, it is fair to say it's headed towards us in the same way that when someone from Asia visits Greater St. Louis, I can say they visited me. Did I see them? No. Was there really any chance I'd see them without getting in a car to take a drive? No. They just were a whole lot closer than normal. This comet, it's only getting about as close as Saturn. Saturn will still be closer though. So the only way we're going to visit this comet is if we hop in a rocket and fly to it. So bottom line, the comet is big, no argument. Giant, awesome comet. It is going to be close enough to the sun, while out at Saturn, that it should get active. You should be excited. Just not as excited as some headlines would lead you to think you should be. As we get more data, we'll keep you updated.
We'll have a full segment on Mars right after this, but first an update on the Ingenuity Mars helicopter. On April 8th, it completed its 25th flight over the Martian surface, traveling 704 meters in just under 3 minutes, at a maximum speed of 5.5 meters per second, another speed record for the helicopter. Ingenuity is continuing its operational mission extension, scouting ahead of the Perseverance rover to help mission planners decide which of two ways to traverse up to the delta at the mouth of Jezero crater. The rover is, for a rover, booking it over the crater's surface, traveling over 300 meters in one day about 50 sols ago. It has traveled 6.6 kilometers since landing. It can only travel at 60 meters per hour, a snail's pace, but thanks to Ingenuity and the relatively flat terrain, plus some other factors, it doesn't have to stop as often and keeps driving day by day. And now we're going to take a look at some more Mars science stories. Stay tuned.
I have to admit, while everyone around here has been rover this, rover that, the Mars mission I was most excited about was InSight. It was supposed to burrow a temperature sensor several meters into the ground and deploy a seismograph that would finally answer the question, is Mars geologically active? Geologically active means the world isn't solid all the way through and is still capable of changing its surface and atmosphere through events ranging from outgassing to volcanism to marsquakes. While that thermal sensor learned the giant sand trap that is its resting place on Mars is not good to try and dig in, the seismograph has been returning remarkable data, and in a new paper in Nature Communications, researchers document that Mars is indeed active. The two authors of this paper have names that make me really wish people put pronunciation guides on their web pages. We have their names written out on our website, and for those of you watching us on TV or YouTube, the names are written below. In their remarkable research, they document 47 new marsquakes that are in the same region as two earlier high-quality events beneath Cerberus Fossae. This region contains fissures that run alongside each other, marking where the crust is pulling apart. These quakes occurred at all times of day and aren't caused by tidal effects. The best fit for these shakes is the movement of magma in the upper mantle on Mars. According to the paper, the continuous seismicity suggests that Cerberus Fossae is seismically highly active and the Martian mantle is mobile. It's impossible to know if this magma will ever ooze out to the Martian surface or if it will simply keep shaking things up. No matter what happens, this seems to indicate that Mars, or at least the part under Cerberus Fossae, is still very much alive.
And now, back to rovers. NASA's Mars rover Curiosity is steadily advancing up its target, Mount Sharp. Currently, it is on the Greenhue pediment, a large flat area made out of sandstone. Near the pediment is an area called the Geddes Vallis Ridge, where there is debris from further up the mountain. The debris is quite large, boulder size, so it must have been transported by water, making it worth studying. Scientists wanted to study them up close by driving along the pediment to take pictures of the ridge. However, the rover is going to need to find a new route up the mountain because of a hazard. Ventifacts are rocks that have been eroded by wind action, and this type of rock has caused damage to Curiosity's wheels before. The Curiosity team calls these rock formation gator-backed rocks because they look like scales. The engineers would like to avoid more damage to the wheels, so over the next few weeks, the rover will climb back down the mountain and resume exploring an area with clay minerals and sulfates, more signs of past water action.
As we deploy rovers and landers across Mars' surface and fill its orbit with satellites, we are slowly being able to explore the hard questions like, how do we predict weather on a world where it snows carbon dioxide? In a presentation at March's Lunar and Planetary Science Conference by Nora Al-Sayed, researchers document how dust plays a major role in Mars weather. This work is now summed up by Kimberly Cartier on eos.org. With stunning imagery, this research documents how the movement of dust instead of moisture regulates Mars weather patterns. For instance, and I quote, "Stronger southern dust cycles on Mars stifle its northern polar vortex and increase its snowfall rate, up to a point at least," end quote. Using 10 years of infrared data to track dust, Al-Sayed looked at the dust seasons on Mars and how they correlated with the fall of carbon dioxide snow. It turns out that more dust is good for more snow. Al-Sayed explains, the Mars dust cycle is very important, and the poles are very important in terms of regulating heat and atmospheric circulation. The fact that they're so tightly coupled makes sense in a way, but it's really important to understand just how that coupling works. This work highlights just how tightly coupled they are, and I hope that more work in the future looks at what the direct line of influence is, end quote. Folks, go check out the imagery used in the story Cartier wrote. It is stunning. We'll link to it on our website, dailyspace.org. And while you go looking, we're going to look back on rocket history. Stay tuned.
This week in rocket history is also about fuel cells, Apollo 13. This is one of the few missions I think most people have heard about, even if they aren't space enthusiasts. However, there are some questions you may have, and some interesting things about the mission you might not know, so this week in rocket history will be all about those. But first, a short summary. Apollo 13 launched on April 13, 1970. 3 days into the mission, one of the fuel cells exploded during a routine maintenance task due to frayed wiring causing a spark. Thanks to an incredible effort, all 3 astronauts were brought home alive and well, though they had to abandon the planned lunar landing. The first question you might have, since the Apollo was only partially towards the moon, why couldn't they just burn and skip the moon entirely? The problem was the big main engine on the Apollo service module, the service propulsion system, was assumed to be damaged by the explosion in the service module. Even if it was fine, the power needed to run it would have caused them to run out of battery an hour before landing. Not a good time for that to happen. So it could not be used, and the mission would have to get back on its free return trajectory using the lunar module's descent stage engine to return to Earth. Right before re-entry, the astronauts took pictures of the service module and saw that the SPS engine was damaged, confirming that not using it was the right thing to do, even if it extended the mission. Another question, did they end up doing any science during the mission when they weren't fighting for their lives? It turns out that yes, they did do some science, or rather, continued science that was started prior to the explosion. The first one happened before the explosion, which changed the course of the mission. Apollo 12, the previous mission, which did land on the moon, was hit by lightning twice, throwing off the guidance system and almost resulting in an abort during ascent. Luckily, they fixed that problem and landed on the moon. But NASA wanted to gather more data on how the rocket experienced electrical disturbances as it traveled through the atmosphere. The disturbances were described as significant and particularly hazardous for launches conducted in barely acceptable weather conditions. Also building on Apollo 12, the third stage of Apollo 13's Saturn V rocket was guided towards an impact with the Moon, where seismic instruments placed by Apollo 12's crew recorded the vibrations through the Moon, helping scientists learn about its composition and structure below the surface. Several other missions continued this practice. The impact of the stage from Apollo 13 was so powerful that it maxed out the gain on the seismometer, despite impacting 117 kilometers away. So for future missions, the gain was reduced. Another experiment was intended to investigate if a satellite could take useful pictures of clouds from geostationary orbit. All the astronauts did was take 11 pictures of Earth at precise times. The returned photographs were of, quote, excellent quality. A satellite called ATS-6 was launched later, in 1974, to prove the concept, with operational vehicles called synchronous meteorological satellites launching that year. The astronauts did take some time for lunar photography, capturing almost 600 images with a 70mm Hasselblad camera of both the near and far sides of the Moon. One final experiment was called the, quote, pilot describing function, a manual control experiment that was supposed to take place in lunar orbit, but was instead done during several other points in the mission. The purpose of this demonstration was to improve a model of how astronauts manually piloted a spacecraft, particularly one where the vehicle flexes around. This flexing was particularly strong in the large Saturn V rocket, impacting how a pilot would respond to it. This couldn't be completely modeled. Engineers needed real data. Millions of people followed the mission of Apollo 13, providing some much-needed public support for NASA, which was waning after the first and second landings. In fact, it had the second highest television viewings after Apollo 11. The Soviets even sent 4 ships to assist in the rescue efforts. Overall, the mission was, quote, a successful failure, according to Commander Jim Lovell. Despite this great outcome, none of the Apollo 13 astronauts flew in space again. Jim Lovell retired 3 years later. Jack Swigert got in trouble from a scandal on Apollo 15 and removed from flight. Fred Hayes flew the Space Shuttle Enterprise for its atmospheric approach and landing tests, but never flew any of the space-worthy orbiters. And now for some statistics. The number of toilets in space is 9, 4 on the ISS, 1 on Soyuz MS-21, 1 on Crew Dragon Endurance, 1 on Crew Dragon Endeavour, 1 on Shenzhou 13, and 1 on Tianhe. We keep track of orbital launches by launch site, also called spaceport. Here's that breakdown. USA 20, China 8, Kazakhstan 3, Russia 3, New Zealand 2, India 1, Iran 1. From those 38 launches, a total of 637 spacecraft were put into orbit. Your random space fact for this week is that NASA sent up a real human skull, detailed secondary objective 469, covered in layers of plastic and thermoluminescent dosimeters to measure radiation levels while in space. It flew aboard 3 space shuttle missions, STS-28, 36, and 31. This has been The Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.